Welcome. I normally do talks about late Cretaceous research I'm doing, and some of you came by and saw some of the stuff upstairs. I thought this locality was late Cretaceous. Research takes us down lots of different rabbit holes, and this ended up being a rabbit hole, and I'll kind of get into it slowly. Some basic things I'm going to try to do. An overview of South Carolina 65.5 to roughly 61 million years ago. The Cretaceous ended 66 million years ago, so this is right after that. I'm going to give a little bit of history, overview, and some of the problems. Along with that, an overview of the animals that I'm finding lived here. And I will wrap up with a basic introduction to some of the ethics and laws dealing with fossil collecting as a state. Every state is different, so what I tell you only necessarily applies to South Carolina. I had South Carolina State Museum's logo on the title slide because I've been working for 20-25 years with Dave Chichamuri at the State Museum. He is a shark expert, fossil shark expert, modern shark expert, all them things. So if some of the shark identifications in your opinion are wrong, blame him, although there's one I'm not sure about and I left it in anyhow. The bad news is he's left the state, he's taken a job in Alabama, but we'll stay in contact and keep working on this project. I've showed this slide at the introduction to my Late Cretaceous project. It's a classic example of trying to deal with paleontology. It's nice to go collect specimens that are whole, not broken and scattered into a million little pieces, but that's not how they usually show up. This is part of a turtle plastron. My bad. Part of a turtle plastron, a sea turtle plastron, just the bottom part of a turtle. This is a project Dave was working on for 5 years. That's where he was after 5 years. And boxes of more stuff. The whole turtle is there. It's just a matter of fitting the pieces together and getting them to match up. I don't know what he's doing with this project now that he's not at the State Museum. I don't know if he's taking it on loan with him to Alabama or if it's just been left there for somebody else to work on. It was a little bit further along the last time I saw it, about a month ago. At the State Museum, you will also find literally dozens of smaller turtles that have been completely reconstructed using fragments. And I just throw that up there as, okay, this is where we're going with it. Dealing with this project and also the Late Cretaceous project, it's like dealing with a puzzle. If you build puzzles, you often use that pretty picture on the outside to guide you in your puzzle making. There's no picture in this case, though. You're just getting pieces and trying to figure out how they all go together. All right. The State Museum used to publish this. They don't anymore. And it came out in, I didn't write it here, but it was published in the 1980s, I want to say. And the reason it's important is it says that this site that I'm going to be talking about is Cretaceous in age, and it's the PD Formation. Everything that I had upstairs that you were looking at is from the PD Formation. And it didn't excite me at the time. I collected some stuff. All right, this slide may be a little out of position, but you get the idea. Cretaceous ended roughly 66 million years ago, and the Paleocene period followed it immediately. I don't like this slide as both a paleontologist and as a geologist, but it's convenient for what I just did. The problem with the slide is it's not to scale. This is better. because it includes, okay, if you take all of Earth history, there's the Mesozoic. The Cretaceous is at the very top of the Mesozoic, and the Paleocene is at the very bottom of the Cenozoic. This is to scale for Earth history. Paleontologists spend most of their time just studying from the bottom of the Paleozoic up to the present. And we generally ignore Proterozoic, Archean, and however you pronounce that one, it's new. Why? Because life as we recognize it basically started right about there or a little bit before that. Life in the fossil record before that is single cells or slightly jumbles of cells. So let's move on. Taking this part, Paleozoic up to the Cenozoic, and extending it out to the same scale, Cambrian, Ordovician, Silurian, Devonian, Carboniferous, Permian, Triassic, Jurassic, Cretaceous. Now we're at the Cretaceous here. And then the Paleogene includes the Paleocene. And then you can extend it out again. And here's the Paleocene at the very bottom of the Tertiary. I first visited REMS in 1991 and collected some blocks that I found there. Again, it didn't look like a promising locality, so I collected it. I could see teeth in it. Okay. I collected some blocks, figured I'd put them in acid at some point and see what came out. The first time I ran them through acid, 2020. What's the point here? Time. Second point, how do I know when I collected it? You got to record everything. What you collect, where you collect it, when you collect it. And I knew I collected it at REMS or near REMS. And in my notes, I also talk about the campground that's there or was there. I immediately realized, looking through the material, that something was missing. Squalicorax cowpea. If you know anything about the Cretaceous, pretty much worldwide, Squalicorax should be there. It's not there. So that rang off little bells in my head. Plus there was other stuff there that I didn't recognize. So I called Dave. And Dave said, that's because it isn't Cretaceous. It's Paleocene. More importantly, it's Danian Paleocene, very bottom of the Paleocene. And we know that because there's been a paper published in the last few years using other things besides vertebrates. The paper was actually published in 1982. I got here in 1989, I collected in 91, but you got to remember that in 1991, computers were still a new thing. Internet was a new idea. So it wasn't like I could easily go online and look for papers that had already been published. Dave knew other different ways, not by being online. And what I want to point out is that the REMS formation, which is named for REMS, South Carolina, has two parts, the Browns Ferry member and the Perkins Bluff member. And as I said, it's part of the lowest part of the Paleocene, the Danian. There it is. Can you see it? That's not it. It is in here where I collected the blocks. Well, some of the blocks. But you can also see that there's a ledge that runs along, and we are looking at it across from the Browns Ferry landing. There it is. Still not very visible. But this is the other side of the landing, right there. And so the locality is right in here. And it also, if you have a boat, runs along that way. That's a view, sort of the locality is right here on the edge, and that's the Browns Ferry Bridge. I am still confused by this paper because the diagrams, and I'm not going to get into this in great detail, but the diagrams aren't consistent. This one shows the stratigraphy, and it says river level. What's the first problem with river level there? It goes up and down. It's tidal, without even worrying about how much rain you've had in the area. So, and tidal variation is about 5 feet during the day. So they say river level there, and I go maybe. And they show that ledge there, but most of the stuff I've collected is supposedly, according to this diagram up here. So was the river, all right, like I said, it's confusing. No doubt that it's Danian age, no doubt that it's the Rems Formation, but exactly the stratigraphy, I'm not sure of. That's another picture of it, right through there. Okay, and then they talk about Perkins Bluff, which is around the corner. I haven't been there yet. Again, same problem with river level. Here looks like at Browns, well, I won't get into that. We'll just move on. Oh, I do want to point one other thing out. Perkins Bluff member is supposed to have a lot of shells in it. That's what those little slants mean. That specimens I collected that I labeled Rems Formation have a lot of shells in them. This is Jim Knight breaking rocks there. This is not a site where you're going to go along and pick stuff up. Sorry. You're going to have to smack it and then put it in acid. There's also a sign there. Notice, the recovery of artifacts and fossils from navigable waters of the state of South Carolina is governed by law and requires a license from the state. And they put that there because there is a boat that was recovered from that locality, where there's still lots of artifacts there, and so you've got divers that are constantly trying to go in there, and so the police hang out at Browns Ferry on a fairly regular basis looking for people trying to either collect fossils and we get into where is the river. Is it river when it's all the way up, or is it river when it's all the way down? And the answer is mean low water is what I want to say. So you can apply for a permit to collect there if you want to. Jim and me out collecting that day. Jim collecting some sediment samples from below. That's the rock that you're going to deal with. The main thing is it doesn't have any shells in it. Remember I said the stuff I collected in 1991 is loaded with shells. The stuff you find here so that was the first problem. I've got this REM stuff, but it has no shells in it. Everything right at this locality doesn't have shells in it. That's another problem. And you can see the shells in the REM stuff I collected very clearly. Breaking rocks, that's how you collect here. You carry them. And then you put them in acetic acid. Acetic acid basically is concentrated vinegar. Nothing fancy. Stinks up the place with the smell of vinegar. And it fizzes. Whoa. All right. Then I take and run it through sieve samples. And then I start sorting and identifying under a microscope. Most of this stuff is microscopic. Not all of it, but most of it. And I now have another volunteer helping me with this process, Nick Rosa. Not everybody has the skill or the patience to do this kind of work. Nick has it, okay? And I'm not going to take the time to show you all this, the finger skills, the manipulation skills you have to be able to work with this stuff, the small stuff. But he's got it, and he's volunteering and helping me with this. Okay, that's the numbers. This is the next size down sieve, what you're looking at. And yes, there's fossils in there. And looking through the microscope, that's a ray tooth. These are sand grains. And then if we go to even the tiniest sieve samples, those of you that saw the little bag of stuff that was so small you could hardly even see it, that's what can come out of those tiny little bags, those tiny little samples. And that's a shark tooth. That's another shark tooth that's upside down. And this is one way I get photography done. You can see the little black spot on the glass slide. That's what it looks like on the computer display. The other thing I can use for slightly larger things is this Zenvo Squid Pro tripod with my cell phone using the Zenvo macro lens. And you see the specimen underneath the lens, and that's what it looks like when I take a picture. All right. People often talk about Cretaceous reptiles. Here's the Cretaceous. A few of those, many of them went extinct at the end of the Cretaceous, but a few of them made it through to the Paleocene. This doesn't really show you the Paleocene, but turtles were in the Paleocene. Crocs were in the Paleocene. Snakes, I haven't gotten any snake material yet. Lizards and sphenodonts. That doesn't talk about fish. The other thing I want to mention, and this is hard for you to see, and I know that, has to do with mammals. And monotremes, marsupials, placentals. Most modern mammals are placentals, but there's another line that comes up on into the Paleocene, the multituberculates. They're not around now, they're gone. They're completely extinct. I'm pointing that out for a reason. That's your local living fossil, a marsupial. Yeah, that's my house. Okay, my kitchen. That's another whole story. Moving on. Okay, Late Cretaceous. I've shown this picture in my, diagram in my talk about the Late Cretaceous. And you look at South Carolina over in this general area, and South Carolina is mostly underwater. The Appalachian Mountains are eroding away. Large interior seaway covering most of the middle part of the country. And what we call the Rocky Mountains are just starting to rise. Well, if the Rocky Mountains are just starting to rise, then in the more recently, into the Paleocene, this says Paleogene, but Paleocene works. Most of South Carolina is still underwater. You got a little bit more sediment as you get up into the Piedmont area. That interior seaway is basically gone and it's been replaced by the Cannonball Sea, and the Rockies are still rising. Okay, so if you had to go look for Paleocene sites in North America, where would you go? I'm just asking in general. You'd have to go where there's seawater, or not seawater, water of some sort. So that means, my bad. You're going to have to go up and down the East Coast, across the Gulf, and then to this Cannonball Sea. For reasons I'm not going to get into, you're not going to find them over here. This is a worldwide map of Danian vertebrate collections. Danian vertebrate sites are not common. If I had Cretaceous, Late Cretaceous up there for comparison, it would just, the map would be covered almost with Late Cretaceous. Not completely, but much more than there is there. If we just focus on North America, basically what was here during the Danian, the Cannonball Sea. This was the area that was underwater. There is one Danian site known from South Carolina up to this point. Now there's a new one. These are Danian sites with any vertebrates at them. If I did a similar picture for Danian sites with multituberculates, there would be 3. This is from my other talk also. People are always coming up to me and asking me what kind of shark tooth is this, and the answer is sometimes I just can't tell. Sometimes I can easily, others it's much more difficult. It's real easy when, did it again, sorry. It's fairly easy when you have a shark with homodont dentition or monognathic, either one. All the teeth are the same, upper and lower jaw, they're just bigger and smaller. So you get a tooth from that shark, you know which one time it is. Easy. When you come down to dignathic, then it starts getting more complicated because they have 2 different kinds of teeth. And it gets really nuts when you get to these guys, where the types of teeth change as the animal grows. Completely changes as the animal grows. So a small example of that species is going to have completely different teeth from an adult. And last but not least, you also have to consider sexual dimorphism. In some species, males and females have completely different kinds of teeth. So that's the first issue. The second issue is this, abrasion. This kind of tooth can eventually get identified. This one, we're getting into the maybe it can be identified, and then these 3, you have a shark tooth. Thank you. Not being mean, just that's the best you can do. All right, so what have we found so far at this site? And this is where I said getting into things that lived here during the Danian. This was a water site, ocean site, so you're going to basically get, for most of the time, fish. And notice that even Dave just said erectolobiform. Not sure which one it is. The Danian is a relatively short period in time. So there's almost very few publications about the vertebrates from that period. It's not like the Cretaceous where there's lots of publications. This is a different erectolobiform. We can tell that it's that family of shark, but exactly which one, not sure. Then we get into the sand sharks, sand tiger sharks. This is Carcharias, the same type that's off our beaches right now. More Carcharias. Maybe Carcharias, not sure. And the problem with this one is right there. We're missing information there. It's not a complete tooth. More Carcharias. Look at how different the teeth are. This is an odontaspid. Again, not even trying right now to get genus. This is one I'm not sure about that I mentioned. Dave says this is Scapanorhynchus. That's problematic. There's people that say Scapanarhynchus went extinct during the Late Cretaceous. Shouldn't be in the Danian, but maybe. That's a modern family member of Scapanarhynchus, not Scapanarhynchus. Mackerel sharks. If you've come to my Cretaceous talks, Cretalamna appendiculata is part of the Cretaceous also. So it survived through the big extinction at the end of the Cretaceous. Paleogallus was also in the Late Cretaceous, so it survived the Great Extinction. Ciliarinids also survived the Late Cretaceous extinction event. This isn't the greatest sawfish tooth, but there it is. And again, they survived the Late Cretaceous extinction. And this is the best we can do with these ray teeth right now. Something in the family Ragidae, number 1, number 2, number 3, number 4, number 5, number 6, rays. Number 7, number 8, number 9. Okay, the rays are very complicated and they're unique. Each one is probably a new genus, which would therefore be a new species. Mylobatid teeth, eagle rays, you find stuff like this right now on the beach. We have eagle rays off the beach right now. Stingray stingers, got those. Now we get into other fish, and they're just as obscure and confusing as, notice I say pycnodont tooth plates. If this was Late Cretaceous, I'd say pycnodont, but it's Danian. So there's other options now. Again, if this was Late Cretaceous, I'd say this is albula, but again, question marks. Bony fish tooth of some sort. Part of a turtle shell. Croc tooth. And this is the thing that gets all the attention. The last time I gave this talk, 4 years ago, that was a big question mark. That's not as big a question mark. I still need to get a scanning electron microscope view of it, but 2 experts are saying, yes, that is a multituberculate tooth. And that makes this site and what's there rare, rare, rare. It also means I have to solve a problem, which I'm in the process of solving. This came out of a block of the RIMS material, which if you go to the site today, you won't find it. There's none of that material there. All that's there are the blocks that I've showed you that don't have any shells in them. So I have spent numerous times trying to retrace where I was in 1991. The problem is things change. First of all, in 1991, when I visited there, it was a park. There's no park now. It's just all overgrown. Second of all, the roads have been changed since then. Walter Hill, the director here, was talking to a friend of his, though, who said, oh yeah, I used to go there all the time as a child and up through high school when it was a park. And he said, well, do you remember a place where you could reach up and there would be blocks of rock that high off the ground? And she said, yes. Well, you go there today, you're not going to find it. And she said, yes, and I can tell you where it was. Well, it was kind of on the other side of where you can go down now, but it's all been filled in, which is why I can't find it. But I wasn't losing my mind with my visual memory, which is normally really good. I remember reaching up and grabbing something, those blocks, and bringing them down. So, yeah, I'm in the right place. Multituberculate. I'll show you what I mean. And multituberculates made it into the Danian. P4 is a particular type of multituberculate tooth. You might recognize that that pattern is what we were just looking at. Wrong way. And there's two roots sticking down. Just like there. When I saw it, how did I know it was significant? Back to that visual memory. I had seen something like that back taking vertebrate paleontology in 1977. Okay. I don't have a photographic memory, but I remember things in images. My memory is all about images. So I had to go look it up, but there I went, yeah, I've seen that. And that's not one of my specimens. It's just an example of another multituberculate. And the critter that it came from, a reconstruction. So we had critters like that running around here. Now, what does that also tell you, though? Where was this locality? It's marine. It was underwater. So Tolotus wasn't living right there. It was living somewhere further inland, and it died or was murdered by another animal for lunch or whatever. And then one of these P4s managed to make it down. They're rare. They're super rare. And this is another picture of the two. That's of the one, excuse me. There's only one so far. It would be nice to find more than one, but anybody that knows anything about multituberculates, since their teeth and their parts are so rare, good luck. Okay. I'm not, how am I doing for time? Okay. People that search for multituberculates and do it because that's what they're really interested in, usually literally get backhoes and go through an entire acre or more, and then have graduate students or some other volunteers take the material and put it through sieves. And if they do an acre or two, they'll find one. Okay? So they're rare, even if you know they're there. And then we get into what is it? We had the ray teeth that we don't know what they are. I mean, we know they're ray teeth, but that's the best we can do. Then we have other stuff where it's bone. We know that. What did it go to? And we're down at, that's 1 millimeter from there to there. It certainly looks like a finger bone or something like that. And it's hard to see in this photograph, but that looks sort of like a skull. Of what? I don't know. Fish tooth of some sort. This sort of looks like the other fish teeth I showed you because it looks the same on top, but this top is punched down in, and it comes out where the root would be. Never seen anything like that. This looks like an anchor. This is a fish tooth of some sort. That's a limb from something. All right, that's basically the end of my talk about that. I got a couple more slides because I want to talk about pareidolia, which is we see something and it has a general shape that we recognize or we think we recognize, and so we call it that. Or they come to the museum with it saying, this is a turtle head. That's the most common thing that gets brought here. That's an example of what people around here call turtle heads, but it's not the only example of things that are brought to us to identify. There's only one problem. If you know what a turtle skull looks like, they don't look like that. I can understand why people call them turtle heads, but they don't look like turtle skulls. Vertebrates have sutures between their different bones in their skull. I'm not going to get into all the suture patterns, but 1, 3. There's another one that's hard to see here. There's one down here. Just examples. Plus, vertebrates will have an upper jaw, or turtles, and a lower jaw. They'll also have an opening for ears. So, when you start trying to find those things on the turtle heads, they're not there. They're not turtle heads. They are, and I saw this being displayed earlier on somebody's display. This is was created down at the Mace Brown Museum of the College of Charleston. What happens to make turtle heads is a clam, a late Cretaceous clam, Cucullia gigantea, dies. And then it gets covered by sediment, and in the process, the sediment goes in between the valves. The valves eventually dissolve, and what you're left with is the inside. Not a turtle head. On the paleontology forums of different kinds, there's people always saying that they've got this or they've got that. They've always got an egg, except it's not an egg. Dinosaur eggs are real popular. Something round is a dinosaur egg to them, or spherical. And the other thing is to be careful if you want to buy any of this stuff online. You'll see stuff like this online. People selling stuff like this saying, yeah, this is a turtle. I've seen people trying to sell dinosaur teeth, and what they have are some quartz crystals, basically, that have been altered so that they're sharp. Dinosaur teeth don't look anything like that. All right. Jim talked about collecting here. I'm going to mention a couple things about collecting here. There's lots to find. Museums like this museum and the State Museum and Charleston Museum depend on, we hope, amateurs. Hobby collectors will go out and find stuff and bring it to us so we can see what it is, okay? My Baculites collection here is the largest in the state, but it's largest in the state because people have brought Baculites into me saying, what is this? Or, oh, I've collected some. And I had another one. If you were here earlier, you saw somebody find something at the beach and bring it into me today. Adds to the collection. I'm not here to talk about Baculites, I'm just talking about the importance of people going out and looking. But please respect property owner rights. And people don't understand. Everybody owns everything. There is no public, I can go do whatever I want to do, land anywhere. The beaches belong to Surfside Beach or Myrtle Beach, or they're not yours. And somebody will say, well, there's a sign saying public access. That means you can go there. It doesn't mean you can go dig it up. Okay? Well, it's beside the road. Who owns the road? Somebody owns it. Now, that doesn't mean people are going to get upset that you come along, well, public access places, roads, public places in general. If you pick something up and you collect it, it's not a problem. The problem comes when you decide to do things more seriously and you show up with a shovel and start digging. Or you decide to show up with your backhoe and start digging. Okay? Because it's a good site. I want to make money. It's not your property to do that with. And they have been big problems down in Somerville because of people just not respecting property rights of owners. They've even put up cameras in some areas so they can catch people and prosecute them. River bottoms. I found it in the Great PD River. Okay. Again, a couple of teeth, not a problem. If you want to dive the Waccamaw River and start collecting lots of shark teeth, and then decide to go online and try to sell them, you're going to raise the attention of a bunch of different people. Because they're going to ask you, do you have a hobby license? You know, picking up one megalodon tooth, probably not a problem until you try to sell it. Picking up box loads of megalodon teeth to try and sell, you're going to get the attention. It's not your river bottom. It belongs to the state of South Carolina. I'm not going to get into the dirty details, but a few years ago, there was a guy advertising on social media that he had either I can't remember, it was mastodon or mammoth skull in a river down in the Charleston area, and he was asking $50,000 for somebody to come. If you'd pay him $50,000, he'd take you to the locality. Bing! Sets off all kinds of alarm bells. He got taken to court. That specimen is now at the State Museum. He didn't get any money for it, and he got prosecuted for it. I don't know what all that came down to, but yes, there are lawyers that keep track of this for the State Museum and also for USC. If you want to start using anything mechanical, or you start trying to advertise online, make sure you have at least a hobby license. Yes, there are people that have permission to dive rivers, collect megalodons, and sell them, but they have to fill out the paperwork where they got the specimens from, how many they got, and turn it into the State Museum. There is a license for it, and there is a way to do it properly. There's a separate industrial license for those of you that want to take a backhoe in somewhere and try to get rich on something. Okay, there is an industrial license for doing that. Hobby licenses are what they're called in South Carolina. Now, again, if you go to the beach with your family and you pick up something and you want to keep it, that's not a problem. Shark tooth, whatever. Same thing on the Great PD River, any of these sites. As long as public access, you pick up something, not a problem. Restricted, if it's private property and you don't have permission, even picking up anything can get you into trouble. But that's between the private property owner and you at that point, and their lawyer. Public access, yes, you can pick stuff up. Just don't go crazy and don't start using mechanical equipment to get it. And don't try to sell it online. These are the same resources I put up for my Late Cretaceous talk. Some of the resources are here. Keep in mind, this is Danian, but quite a few of the Cretaceous things made it through to the Danian, so they're still useful for figuring out some of the Danian. And the real big problem with the Danian is the number of actual resources on Danian stuff is very limited, and no generally publicly available stuff. Facebook, again, back to the Somerville issue. I've seen videos posted of people using lights at night down in Somerville in places where they obviously shouldn't have been, and they were doing it at night for that reason. The other thing I have to say about Facebook, take identifications that people give you on Facebook with a grain of salt. Do want to acknowledge a couple of people, and then this is basically, I got trained as a geology at James Madison University. Lynn Fichter is still teaching there. I graduated in 1979. He's still there, teaching paleontology, invertebrate and vertebrate. From there, I spent my senior year at the Smithsonian, did a senior thesis there. Bob Purdy is still there, he's retired, but he's still around. And then I went to the University of Kansas, where my advisor was Dr. Hans-Peter Schulze, who's still there. He specializes in fish, if you're trying to figure out where I get all my training from. Like Jim Knight, we both left the University of Kansas. We were grad students together there. He left the University of Kansas the same year I did for similar reasons, but I don't want to get into that. That's a whole separate ballgame. But Jim then went up to Harvard and worked for a couple of years, and then he came down here and worked at the State Museum until he just retired a few years ago. Walter Hill is the director of this museum. Dave Chichimuri, I've already talked about. More recently, Amanda Milhouse I've been working with at the Smithsonian, and Hans-Dieter Seuss. Bob Denton is on this list, even though it says he's a senior geologist with Terracon, which he is. He's also somebody who's published papers on multituberculates. And he's the guy that said, yes, you have a multituberculate P4 from this site. It's rare, it's very rare. You need to follow this up and get more stuff in acid and see if we can get more. And so that's why his name is there. And last but not least, I put Dr. Stephen Leslie on here. He is the current chair of the Department of Geology at James Madison, and he has invited me to bring there any specimens I would like, I guess, photographed, that's not really the right word, with their scanning electron microscope. So that solves the SEM problem. It's just a matter of me deciding what needs to go have an SEM done and schedule it so that their students, undergraduates and grad students or faculty aren't using the SEM at the same time. So, my desk, my chaos of different things going on. It's hard to see, but each of these represents different sieve samples from different sites, Late Cretaceous or this Browns Ferry site. And there's more of them off to the sides. So work on one for a while, get tired of working on it, go on work on another one. And that's it. Thank you.